Welcome to my new calculus channel. My name is John Gabriel. And today I'm going to take a short break from my video series called What Your Ignorant Educators Could Not Tell You, and give you a special presentation on a topic that is very dear to my heart. Now, before I do that, let me just say that the series, What Your Ignorant Teachers Could Not Tell You, is going to be ongoing. There is so much information that I have to cover that I doubt I can cover it, even if I could live another maybe 200-300 years, which I'm sure I won't. So let's begin. Now, I've already covered this this webpage that was created by that idiot PhD student, Dennis Muller, a moron from somewhere in Germany. So, but it's kind of close to my heart because I look at all the idiotic things he says. And so, for example, he comes down here and he says, here is Gabriel's definition of a function limit. And then what does he do? He does exactly, and by the way, his is wrong because, well, okay, it's stated a little differently, but it's equivalently the same. Now he says, now why did I put a lower index epsilon? You see this little red epsilon here and here after the delta? And then he says, well, and this is his poor excuse. A formula for all epsilon, there exists a delta x, means that the exact value of delta whose existence is posited by the formula may depend on the specific value of epsilon. You can think of it as a function f of delta, but isn't that exactly what I did there, epsilon of delta? So that maps each epsilon to some specific delta, okay? And then he gives some irrelevant crap here, which is not important, and I'm not going to waste time on it. The point being, the value of this delta function may depend on your choice of epsilon. Well, of course. I mean, if you, and by the way, although I stated epsilon in terms of delta, it can be stated either way. And in my article called the geometric limit theorem, it's a brand new theorem which I discovered. I have actually made it easy to dispense with all epsilon delta arguments. And so in this particular article, I explain to you the entire derivation of my theorem and show you that you can have epsilon, as you see here, in terms of delta, and delta in terms of epsilon. And these inequalities are explained and visually in the applet. So explained and visualized dynamically in the applet, in this particular applet. And I'll show you in a moment what that applet does. So in my new applet here, the theorem states that if this is true and L is the limit, provided L will be the limit, provided the area of this circle, which is given by this formula, reduces to 0 as x approaches c. So as this x approaches c, the area reduces to 0. As it gets further away, it increases. This is true of every single function that is smooth, and there are no exceptions. And if you don't believe me, what you do is you come down here and you type in another function, okay? So move this closer like that, let's say, and type in another function. Let's say f of x equals to x. And the same story, okay? If you move the point away, the area increases. And if you move it towards, the area goes towards 0, okay? So that's, and you only have, the beauty of this is you only have to prove it once, and you never have to mess with epsilon delta proofs or definitions ever again. And you can do the same thing with any other function. Take f of x is equal to x squared. Okay, same story. So if you move away, then it doesn't matter where you are, by the way. If you move towards, it'll decrease, and away, it will increase, okay? And it can be any function you like. So sine of x, for example. I don't know why it's taking so long. It's probably because I'm recording. But come on. This is the nasty thing. Okay, so there it is. So we want to, if we move towards the point, it goes to 0. If you move away, it increases. It doesn't matter where we are, okay? It doesn't matter about inflection points or anything. So this is a beautiful theorem I discovered. Nobody else before me even came close to it. And the reason I discovered it is because I saw through the bullshit of FOL, which is first order logic, and the very fact that the initial statement that is used doesn't mean the same in mathematics as what it means in first order logic. So, for example, if this here is true, well, if this statement is given, then L is the limit, because this here will reduce to 0 as x approaches c. And it can be shown generally so that it never has to be shown again. And of course, the proof of this is given right at the end of this document, okay? And here's the proof of it. So you can go through that in your own time. Now I want to go back to our funny friend here. He's not really a friend, he's a moron, Dennis Muller. So he says, you know, he turns it around and says delta expressed in terms of epsilon. And if you actually have to take a look at one of my articles in which I talk about the new inverse method, okay? So where I talk about the new inverse method, you can look through these articles. They're all available publicly. You'll see in my inverse method that I show this new limit. Let's look at this method here, the new method limit example. I show you, in fact, that you can, that I use delta in terms of epsilon, okay? So the moron must have looked at this even before he wrote his webpage, because in this example, I only use that particular formula, but it doesn't matter which one you use. The reason I use that one is that it's easier to work with, okay? So then he says, point being, delta epsilon may depend on your choice of epsilon. Okay, and this makes sense if you think back to the game interpretation. So the little dimwit who was brainwashed by his educators remembers this very clearly. You give me some arbitrarily small number epsilon, and in response I choose a value delta depending on your epsilon such that the formula holds. Well, now this idiot doesn't understand calculus. He doesn't understand limits. How could he? His fucking moronic professors don't understand it. Come on. How can somebody like this understand if nobody before me actually understood? That's a big statement, but I'm about to show you why it's true, okay? Now, I don't know why this here isn't loading. Okay, let's just give it another click. Right, here you go. So in this particular article, I show you by using delta epsilon, just like the moron uses delta epsilon here, okay? So he's probably seen this, but this is my inverse method limit, my inverse limit method, which eliminates the need for inequalities entirely. And it also works for every function. So I've got two alternatives which are sound, which actually correct the idiotic ideas in your moronic mainstream calculus, okay? In other words, they tell you what you didn't understand about your own calculus. And of course, then I'm about to tell you why what you understood is actually flawed and you're a bunch of fucking morons, okay? So that's the next step. Now, sorry, I always get very worked up when I see these despicable little bastards who think they know. He's actually suffering from Dunning-Kruger, just like his lecturers and his mathematics teachers and everybody else that came before me who think they actually understand mathematics. but they don't. All right, so now let's just go to the presentation that I wanted to give you, okay? So now, what does all this bullshit mean, and where did it start? Well, it started with Cauchy, who basically said that you can find the limit by making the distances, and let's just see, by making these distances smaller and smaller, so that the smaller one becomes the closer the other one gets to the limit point, which is here, okay? So this is a limit. And and I'm about to show you now, and watch carefully, because I have very deep understanding. I am actually smarter than you at any mathematical concept, okay? I understand mathematics better than anyone in history, possibly with the exception of Archimedes. But if so, I would be on his level. Now, anyway, so now, what's happening here? Okay, what's happening here? So what did Cauchy say? Cauchy said that when you do this and you get closer like that, then the distance can be made infinitesimally small. And obviously, if you talk about infinitesimally small, you're talking about infinity, okay? Because if infinity is a acceptable concept to you, then so should be infinitesimal. But now this is where the game of you give me an epsilon and I find you a delta is explained. Okay, so you can pick any particular delta that you like. So as you can see here, I moved this green spot, and I've got the same deltas on either side of the point I'm talking about. And now here, I'm not talking about derivatives yet. I will in a moment. But here, I'm talking about function limits, okay? In other words, a limit of the function at this point. And don't worry, I will upload this applet so that you can play with it on your own time. Now, so see, then I set up my deltas, and then I pick an epsilon here on this side here, okay? And I usually pick the smaller one. So the smaller one says 0.655, right? You see here, the length of this red line is for 655, and the length of this red line here is 0.40657, and I'm going to increase that line to try and make it approximately 655, all right? So 655, so it's okay so far. Oops, now I've gone too far. You see, if this becomes bigger, then this part of the delta is not valid for the epsilon I chose. So if I chose 0.655, this region from here would not be valid, right? So as soon as I bring it back to about 655, let's go about there. It's very difficult to drive this. Say 6, a little bit more. Okay, that's almost there. And there, it's hard to get it to. All right, that's about close enough. So these are almost the same now, right? And I show you using also the inverse limit method that I showed you, that the exact delta is 0.28647, okay? This is the exact delta. And I give you a systematic way of finding it without inequalities, which you don't have in your bogus calculus. In your bogus calculus, you take the absolute value of x minus c less than epsilon over this value here. And then you work out approximately a delta. But this delta may not even be correct. And as you can see, it's only correct if you already know the delta. So again, the beautiful circularity in mainstream mathematics. Mainstream mathematics is full of circularity, okay? And, and so it doesn't matter where you position even this point, okay? You can change the point and then find the delta, all right? I mean, then find the epsilon and then find the delta that works for it. So inside here, it all works. As you can see, all these deltas are mapped to this epsilon here, but not all the deltas on this side here will be mapped to the equal 0.655 red line epsilon on top of the limit point, right? As I've just shown you. If I continue going like that and I exceed, see, false. this statement is no longer true, all right? 0.69 is not less than 0.655. So that's just utter nonsense. Now, so this is what the idiot Weierstrass came up with, which supposedly was intended to rigorize. But did it really rigorize? Well, let's just look quickly at the important facts. One, let's just look at the first one. As with all these, which I call verifinitions because they're not definitions, one must know the limit L, right? So that's the first thing. So in this case here, you may have a function to find L, or a series, or some sort of formula to find L. But in many cases, you cannot find L. What if L was pi, right? In that case, then you can't even begin to use this definition here because L is pi. And so what are you gonna verify with this bullshit here? Nothing. Do you understand that? In other words, you've been a complete and total moron, and I, the great John Gabriel, am educating you. Okay, I'm opening your eyes and those of all the morons that came before me. It's not that I don't understand, you idiots. It's that I understand damn well, and I'm telling you, you are wrong, okay? And I would be a crank if I told you you were correct, because you're not correct. Now, in any case, this was carried even further in other publications, such as Grabiner's publication, who gave you the epsilon delta and all that other crap. Now, if you go to university, you will see your professor try to explain these things to you. The fucking moron probably doesn't even have 1/10 of my understanding. I don't give a shit who he is. You can get even an Abel Prize winner, and they do not have my intelligence. Do you understand that? In other words, I'm telling you that I know this stuff better than anyone else. So somebody who says, I don't understand limits is obviously a crank. Yeah? Okay. Now, in fact, I've even come up with 2 other methods that explain these as well, which don't require inequalities, as I've just told you earlier. Now, let's put aside for a moment the function limit and take a look at how the derivative is redesigned in terms of this machinery, okay? So the moron, Weierstrass, or whoever actually came up with the definition of the derivative, the ubiquitous one, in other words, the limit of this finite difference ratio, applied this verifinition that you see here with epsilonics to the derivative. Right, excuse me. So, and watch how this actually works. In fact, it doesn't work because, for starters, not only must you know the limit, which you don't know the limit because this here never gives you the limit, there is also not always a systematic way to find L. So in the case of this finite difference quotient, there is no systematic way. The first principles method is flawed. You don't say H is not 0, and then you go and you divide by it, and then you actually set it to 0 to find the limit. You may say, no, we're not doing that. We're assuming the limit of this finite difference quotient. No, you fucking moron. You're doing the equivalent of setting H to 0. Otherwise, you don't have the limit. Do you understand? Oh, I get so angry when I think about these idiots thinking that they know this better than me. I could break their heads. Now, neither Cauchy nor Weierstrass removed infinity because as small as you like means the same thing, you stupid. Do you understand that? When you tell me, give me an epsilon and I can find your delta, you're not smart, you idiot. You're a douchebag. Okay? And you're doing exactly that. You're telling me that you can get an infinitely smaller delta set to match my epsilon. So, okay, I'm taking this epsilon here as a reference. So it doesn't matter how small I make it, you'll find me a delta, all right? So over here, you'll just, okay, if I had to do this right now and just remove this, you'll see that this here is false, okay? Because this here is not true. But if I move this within range, then suddenly everything seems to work, right? And what you do is you say, oh yeah, I can just keep on making it smaller. that doesn't even rigorize bullshit. I mean, it doesn't rigorize anything. Do you understand? You idiots, do you understand that? Grr. I must control my anger. Okay, you're unbelievably stupid. The majority of you are. Sorry, there are some of you who are intelligent, but the majority of you are unbelievably stupid. And if you're a mainstream academic, you suffer from syphilitic brains, okay? Now, so what happens here, by the way, if you're looking at the limit of the difference quotient? So really what you're doing here is you're finding the limit of this finite difference quotient, but you have to know the limit. You have to know over here that the slope of the tangent line at this point is 2. You have to know that value of 2. How do you find the value of 2, you idiot? You find it by using your bogus first principles method. It's bogus. It's as wrong as when Newton actually discovered it today as it was then. Okay, so Newton and Leibniz were blithering idiots compared to my intelligence. I am the first and the only to produce a rigorous formulation of calculus. No one before me produced it, okay? And did I invent it? Nope, I discovered it because well-formed knowledge is something which is not invented. It is discovered. If you read my famous article on LinkedIn, what does it mean for a concept to be well-formed or well-defined? You will understand what is a well-defined concept and how to determine if a given definition is even worth bothering with. But this here is not even a definition. It's a verifinition, okay? It doesn't rigorize shit, right? It basically just says, it basically just states the property of a smooth function, which also happens to be continuous. And by the way, in both of these cases, for a function limit and the limit of the difference quotient, you are assuming that the curve is smooth. Because get this, calculus does not work for functions that are not smooth, okay? If you are talking about an interval that has a discontinuity or a kink in it, in other words, it's not smooth, calculus is null and void. You get it, idiots? Right. So now let's summarize. Let's summarize. Neither of these mathematicians, Cauchy nor Weierstrass, removed infinity because as small as you like means the same thing as what you're stating in terms of Cauchy's original definition, which he used both the terms infinitesimal and infinity, okay? And cloaking this limiting process by using inequalities, as we've seen in these epsilonics, does not remove the infinity concept or make it rigorous. Your bogus calculus was never rigorous, okay? Never. And so, well, I hope that you've learned something from this and that you will take a look at the articles and the applets that I have uploaded in the link, and that you will go to the site and tell this fucking idiot what a crank he is, this Dennis Muller, this dirty, hippie-looking piece of crap from Germany who's supposedly a PhD student. And I am livid when I see that this is the moron. Look at him. This is he probably smokes hash and doesn't clean his room, and he's a pig and whatever else. I mean, I'm just angry right now. So, and I'm not thinking calmly, but let me tell you, when I'm gone, the whole world is going to realize my worth, and then it will be too late. And so, well, I'm kind of tired right now. I guess I get too excited and too worked up. But it makes me angry when these Dunning-Kruger individuals think they can actually, you know, go toe-to-toe with me. Nobody can, Okay, nobody, right? So, and if I tell you not even God can measure square root 2 or pi, and that you cannot represent any number, any incommensurable magnitude in the decimal system. In fact, you cannot even measure rational numbers in certain radixes. For example, a third cannot be measured using base 10. And the proof of that is dead easy. Okay. And I've shown you many videos with that being described as a fallacy. Also, I exposed the fallacy of Euler's S equals to lim S. So please play with these applets, especially this one here. You'll find it fascinating. It doesn't matter what function you type in here. My theorem works, okay? This theorem is brilliant, all right? In other words, if you don't want to study the new calculus, this uses what you know about your bogus calculus to help you understand your bogus calculus better, okay? So, and this doesn't have, this theorem, once it's finished, doesn't have any inequalities, all right? The theorem is pretty straightforward. All it says is that as this point moves away, the area of that ellipse or circle increases indefinitely. And as it gets closer, the area reduces to 0 until finally you have 0. Now notice in this particular applet, if I'm looking at the limit difference, it's never defined at the point of tangency. So if I go there, look, 1 minus 1 over 0 minus 2. So you see, what is the limit? You have to know this limit of 2, all right? You have to know it. And as you can see, this here gets closer and closer to 2 because the value of this gets closer and closer to 0, right? See that? But now you don't get this kind of nonsense in the new calculus. There is no infinity or infinitesimals or any other ill-formed concept. Well, I've talked quite a lot. I hope you've enjoyed this little presentation and that you'll join me again in my continuing series. So I'll probably pick a topic that's more on the level of those who are beginners in mathematics. This is really meant at undergraduates and postgraduates and university professors who are as stupid as they come. So I'll end off here. I'm John Gabriel, and this is a New Calculus channel. Till next time, goodbye.